Okay, so let's resume the class. So first of all, I need to apologize that I made a mistake. So I told you that there is just one more simple example to talk about, but there are actually one more hard example and another simple example to talk about. So which one you prefer first? Do you want a simple one first or a hard one first? Hard one. Okay, good. Okay, that's good. Okay. Okay. So this is a story that happens, let's say, in Hogwarts. Where is it? So somewhere in England, right? Yeah. So this is the place where the magical school Harry Potter attends is located. Okay. So this is a story. So we have a conversation between these two persons. One is Ron. Okay. And then let's say the other one is, I don't know how to, Hermione. So I don't know how exactly this name is pronounced. It's like Hermione or whatever, okay, or Hermione or whatever. Okay, so let's say there are two persons, a boy and a girl, okay, and then Ron wants to show off, okay. He wants to tell Hermione that in the summer he has been working very hard on this spell. The name of the spell is this one. This is a famous spell, okay, in the whole story. This is the Wingardium Leviosa. Oh, very good. Yeah, so why is it very famous? Okay. Leviosa. Okay, so why is it very famous? It is a spell that uses in the first book and also in the last book, and then at a critical moment, right? Wingardium Leviosa. Okay, if you have not read the story, I won't tell you. If you have already read the story, you will probably remember that this spell is used in the first book, well, when you fight very good, the troll, and in the last one, and this is also a critical one, is it? The simplest spell helps the fighting of the big boss, okay, in the end. Yeah, so what does Ron tell Hermione? He told Hermione this story that in the summer, it's not in the summer, it's in April, okay, I should say. It's in April that he has tried to practice this spell a lot, okay, at least once per day. So at least one time each day. And then the total is exactly, wow, this is a very difficult problem. So the total is exactly 45 times. So it's quite natural, right? So on average, he is practicing this spell 1.5 times per day, right? But then what is special or what is most difficult to prove is that we want to show that, so let's say he may be practicing this one time in day 1, twice in day 2, one time in day 3, 3 times in day 4, maybe lazy in day 4, lazy in day 5, lazy in day 6, and then maybe 7 times in day 7 or whatever. So these are the days, the number of times that he's practicing this spell each day. We want to show what? We want to show that there is always some contiguous days. We can find some sequence of days that are contiguous. Contiguous. No gap. There is no gap. Contiguous day, such that the total number of spells, the total number of times that he has practiced is exactly equal to 14. Wow, this is magic, right? Yeah, this is difficult to prove. So you have very few information. You just have what? You just know he's practicing at least once per day. There are 30 days in April, a total of 45 days, or 45 times. But using this minimal number of information, you can somehow deduce that there must be some consecutive days. The total number is exactly equal to 14. So this is exact, and this is exact. So if I'm saying that this is greater than 14, then this is very easy to prove. How do I show that there is a contiguous sequence of days such that the total number of spells that he practiced, the total times is greater than or equal to 14? So it is so easy. you take all days, the whole month. Because the whole month he's practicing 45 times. So this is satisfying this criteria, greater than or equal to 14. Okay? And then perhaps you may say that, how about smaller than or equal to 14? Then this is also easy. You cannot, you will see that, okay, because there are how many? There are only 45 times, okay? And there are 30 days in April. So you cannot practice 2 times each day, because that will be more than 60 times. Is that okay? So some day, there must be exactly 1. So if you find some day that is exactly 1, so there is a day, you can find a contiguous sequence of day, just 1 day, that is less than or equal to 14. So to prove that it is less than or equal to 14, it is also simple. But what is not simple is you are showing that there is really some contiguous sequence of days that is exactly 14. Maybe let's take a look at this example. Do we have this 14 already? Yeah. If you have this example, this hypothetical example, so you have already this from this day 1, 3, 1, 1, 1, 7. Yeah, this I just create this randomly. Then 1 plus 3 plus 1 plus 1 plus 1 plus 7 is exactly equal to 14. Is that okay? So, but here this is just what I try to create. There can be other possibility of the distribution of times over these 30 days. But no matter which distribution, there is always a sequence, a contiguous sequence of days. The total number is equal to 14. Okay, too hard. This is too hard. I find it too hard. Yeah, this is the problem that I've read it. I teach it every year, and then I still need to memorize this. Okay, so let me tell you quickly how we can show this. Again, this is by Pigeonhole Principle. Okay, but not that trivial. Now to solve this problem, let me introduce a new concept for you, but this is very useful. This concept is called prefix sum. Okay, so there are 2 words. You know what is sum, and then what is prefix. Okay, so if you have an English letter, for instance, banana. Okay, so this is that word, banana. If you start from the beginning and end at any position, let's say this one, banana, okay, then we call it a prefix, okay. So you can have a B as a prefix. You just start from B and end at B. You start from B and end at A, you have ba, and then you have ban, and then banan, okay, banana, okay. Okay, you have all this, okay. You have all this. So if you start at any location, start at the beginning and end at any location, then this is called a prefix. Is that okay? So there's an opposite, okay. So opposite, if you start at the end and go back to the forward, so to include the things, okay, or I should say, not start from the end. It should stay, I should say, if you start at any location and go up to the end, so you can start at this one, you can start at this one, go to the end, you can start at this one, go to the end. So you have banana, anana, nana, ana, na, and a. Okay, okay, good. Okay, now this is another name. So this is not called prefix. Anyone know what this is? It is called, if you prepare to take any English test like GRE or TOEFL or whatever, then you will probably want to know. So this is called the suffix, okay? So usually, the meaning of a word, usually you can guess it from the prefix and also the suffix, sometimes, okay? Because, so this is called suffix and this is called the prefix. So usually pre means that you are at the beginning. You prepare for something, you pre-process something. Pre means before, okay? Suff means after, okay? So prefix, okay? So what is prefix sum? Okay, as the name suggests, if you have a sequence of numbers, then we can define this one, this is the prefix 1. We can define this one, this is the prefix 1 and 2, so you get the sum. This is a prefix, another prefix, 1, 2, 1. This is another prefix. So we can get the sum of each prefix and write it down. So for this particular sequence, you can have a prefix sum. If you stop it at the first location, the sum is equal to 1. If you stop it at the first two locations, the second location, the sum is going to be equal to 3. Is that okay? And then we will have 4, and then we will have 7, and then we will have 8, and then we will have 9, and then we will have 10, and then we will have 17, and so on and so forth. Is that okay? So this is called the prefix sum. Okay? Is that okay? So there are 30 days. So there are 30 days. So we write down the number of time that Ron is practicing each day and then obtain a prefix sum. So this prefix sum contains 30 numbers. Is that okay? And then the last one, what is the last one? If you still recall the question, the last one has to be equal to 45. Is that okay? Is that okay? Is that okay? Now, now what we are going to do, we are going to create another sequence. So this sequence is simply what? Simply I write down 14 here. Is that okay? And then add 14 to each number here, except the last. Okay, let's say the last one is 44, and then we get 45. So let's say this is not necessarily 44, but let's say in the example this is 44. So I've written down 14, and then add 14 to this. So you have 15. You add 14 to this, you get 17. You add 14 to this, you get 18, and so on and so forth. And then you add 14 to the last one. So the last one is going to be 58. Is that okay? Is that okay? Okay. Now, so I have two sequences. And then what I'm claiming that two numbers in the sequence. So there are some two numbers among. So how many numbers are there? There are how many numbers? There are going to be the 30 numbers here. And then there are also 30 numbers here. Am I correct? So I'm claiming that these 60 numbers, two of them are equal. Why? Yeah, can you give me the reason why? So there are a lot of numbers here. But no matter how you... Okay, so the first one is defined by the prefix sum. Is that okay? The second one is you add 14 to each number. Except the first one. The first one is 14. Is that okay? You add 14 to each number. And then I'm claiming what? I'm claiming that two numbers here has to be equal. So in this example, you find that, 17 is equal. So you find two numbers here equal. Why? So there are 60 numbers, right? And what are the values of the numbers? So the smallest number must be 1, right? What can be the largest number? The largest number is 58 or 59. Am I correct? Okay, let's say 59. Okay. So there must be two numbers equal. Because there are 60 numbers, and then each of them is chosen from 1 to 59. So you must have two numbers equal. Is that okay? Okay? Equal. Okay, two numbers equal. And next one is, okay, let's say there are two numbers. Let's call it x and y, they are equal. But then, I'm claiming that this x and y, they cannot be in the same sequence. So you cannot find x, y to be the same here. And you cannot find x, y to be the same here. The reason is that you are playing a game at least one time each day. Am I correct? So that all the numbers here have a different at least one. So you cannot have x, y to be in the top sequence. You cannot have x, y to be in the bottom sequence. Is that okay? So one must have x here, and the other must have y here. Is that okay? One of them is at the top, and the other one is at the bottom. Is that okay? Okay. Now, this is what we need. Okay, let me write down. Okay, so there must be some number x, and there must be some number y that comes from the two sequence such that x is equal to y. Is that okay? Okay, what is x? X is the sum of the first, so let's call each term. Again, let's use S1, S2, S3, up to S30 to represent them. Okay? So there must be some S1 plus S2 plus dot 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 up to Sk that adds up equal to x. Am I correct? Because x is the prefix sum. And there must be some 14 plus S1 plus S2 plus dot 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 up to SL. That is equal to y. Okay, because y is equal to 14 plus something here. Is that okay? And then you are claiming that these two are the same. So these two are the same. So I can remove this. So you must have something like S1 plus S2 up to Sk is equal to 14 plus S1 plus S2 up to SL. Is that okay? What do we know? We know that this has to be a longer sequence. This has to be a shorter sequence. This has to be longer, right? Because you have 14 here. This has to be shorter. So you have S1, S2 up to SL. And then let me write it down. So I should have what? I would have S1 plus S2 plus dot 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 up to SL. And then SL plus 1 plus dot 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 up to Sk is equal to S1 plus S2 plus dot 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 up to SL plus 14. Is that okay? So we are claiming this. We are claiming that the sum of a very long sequence is equal to the sum of a shorter sequence plus 14. Is that okay? Does that make sense? We are saying that this one is equal to this one. Okay. So this part must sum up to exactly 14. Is that okay? Yeah, because they have the same, this one is equal to this one. So if we cancel these things out, this remaining part has to be equal to 14. Is that okay? Does that make sense? So we're claiming a long sequence, you add up to equal to 14 plus a shorter sequence. And then both sequence starts with S1, S2, but this ups to SL, this one ups to a longer part, SK. So if we cancel the same first part, the remaining part has to be the same because they are the same at the beginning. Is that okay? So that's it. So take a look of this example. Take a look of this example. So we are saying that 1 plus 3, we are saying, so we discover two numbers that are equal, 17 and 17, am I correct? They are equal. So how do we get this 17? This 17 is equal to 1 plus 2 plus 1 plus 3 plus 1 plus 1 plus 1 plus 7. So this 17 comes from, you sum things up to this 7. Is that okay? Is that okay? And then how do you get this 17? This 17 is, you are adding 1 plus 2, and then you add this with this 14 magic number here. Is that okay? You have 17 equals to 17. Both starts with 1 plus 2. So you must have this remaining part equal to, you sum this up equal to 14. Does that make sense? Yeah, this is what we are doing. Okay? Okay? If we cancel the same beginning part, we will have the resulting part. This one equals to 14. Okay? And then we're done. So this is we have found a contiguous days such that the total number of times this spell is practiced is exactly equal to 14. Okay, if you like this proof, you can show that there must be some consecutive days such that the total number of spells practiced is equal to 15. You can, how about 16? 16 may not work, okay. But I guess with a better argument, you can still show 16 is correct, okay. But at least you can find, using the same proof strategy, that there must be contiguous days such that the total spell practice is equal to 1. there must be contiguous state such that the total number of spell practice is equal to 2, and so on up to 15. You don't have any problem. Okay, 16, maybe you need a stronger argument. Okay, so this is the so-called very, very hard example. Okay, easier one. Okay, easier one. So let's practice one more with the prefix sum. Okay.